Hello, I am Satya from ECE. I am explaining about simplex algorithm method using Python and my roll number is 620218. Our contents is introduction of simplex algorithm, equations, examples, Python code for simplex algorithm and some applications. Simplex algorithm is a popular method for solving LPP. Given a linear objective function and set of linear constraints, the goal of linear programming is to find the values of the decision variables that optimize the objective function subject to constraints. It is an iterative algorithm that involves creating a W, which is a matrix representation of the problem, and repeatedly performing pivoting operations to update the table until an optimal solution is found. It can be implemented using either the Scipy library and NumPy to perform matrix operations. The algorithm involves creating a simplex table, repeatedly identifying the pivot column and pivot row, and performing pivot operation until the table converges. The optimal solution can then be extracted from the final algorithm for simplex algorithm method. First, we initialize the simplex W. Identify the pivot column as the one with the most negative quotient in the last row. Identify the pivot row as the one with the smallest non-negative ratio of the RHS to the corresponding quotient in the pivot column. Update the W by performing row operations to make the pivot element equal to 1 and all other elements in the pivot column equal to 0. Repeat steps 2 to 4 times until all quotients in the last row are non-negative. The solution is given by the values of the decision variables in the last column of W, and the optimal value of the objective function is given by the negative of the value in the bottom right corner of the W. Here is the flowchart for solving simplex algorithm problems. First, we take the objective function and check all constants. Select the largest positive quotient, say Ci, that is the pivot column, and identify the pivot row by dividing RHS with quotient of pivot column. By repeating these steps, we can get the optimal solution for the objective function. Equations for simplex algorithm. We can minimize or maximize by this method. First, we take objective function called z is equal to c1x1 plus c2x2 and so on, and the constants are a11x1 plus a12x2 and so on less than or equal to b1, and a21x1 plus a22x2 and so on less than or equal to b2 and so on. These are the constants for given objective function, where x1, x2 are the and so on are decision variables, and c1, c2 and so on cn are quotients of objective function. A11, A12 and so on are quotients of constants. B1, B2 and Bm are RHS of constants. The simplex algorithm works by constructing a simplex W that represents the problem in matrix form. The W is a m plus 1 into n plus 1 matrix that has the following form as shown on the screen. The simplex algorithm iteratively performs pivoting operations on the W to find the optimal solution. The pivoting operation involves selecting a pivot element, which is the element in the W that will be used to eliminate other elements in the same column, and then performing row operations to eliminate all other elements in the pivot column. This process is continuous. All quotients in the last row of W are non-negative, at which point the optimal solution has been found. Here is the one example. We take objective function is 2x1 plus 3x2. We want to maximize this objective function, and the constants given are x1 plus x2 less than equal to 4 and 2x1 plus x2 less than or equal to 5, and decision variables are always greater than or equal to 0. We can initialize this problem by forming table. We take the quotients of constants as these rows and RHS values at right side and quotients of objective function at bottom. By identifying pivot column, which is the column with the most negative quotients in the last row, in this case the pivot column is x1 since its quotient is -2. Identifying the pivot row, which is the row with the smallest non-negative ratio of the right RHS to the corresponding quotient in the pivot column. The pivot row is R1 since the ratio of the RHS is 4 to its quotient in the pivot column, which is the smaller than the R2. Update the W by performing row operations as shown on the screen. This is the W2. Repeat the process of identifying the pivot column and pivot row. Final W is this. We can get the values of x1 and x2 as this 1, 3 and the optimal solution for the objective function is 11. It is the code for simplex algorithm method without using SkyBay library. This code can be explained as we take the objective function z and constants where our decision variables are always greater than or equal to 0. A is the quotients of constants x1, x2 and so on xn. B is the RHS of constants. C is quotients of x1, x2 and so on of objective function. A is m into n matrix. First we initialize the method by constructing a matrix m plus 1 into n plus 1 and we fill it the matrix with zeros in step 2. After that we fill the m into n matrix with the quotients of constants a11, a21 and so on. After that we fill the right hand side column with RHS values of constants, and in step 5 we fill the bottom row with quotients of objective function as shown on the screen. By row operations we can get the optimal value at this point 0 and we find the values of x1 x2 at the RHS side as shown in example. And this is the code. As we said, first we take the shape of A, that is m comma n, and we form the matrix m plus 1 comma n plus 1 and we put the A values and B values and C values as we explain in the example and performs the row operations. This is the row operation step. Argmin is used for the minimum value of the row. And by ratios we can get the RHS with the quotients of pivot column. By this we can get x and z, which are the values for decision variables and the optimal solution. We take the same example as shown on PPT. These are the quotients for constants 1, 1 and 2, 1 and B is the RHS values of constants 4, 5 and C is the quotients of objective function 2, 3. This is the code and we will run it. 1, 3 is the values for decision variables x1 is 1, x2 is 3, and optimal value is 11. We get the same value in this example 1 comma 3 and 11, and this is the second example. We take the 3 into 3 matrix of A and we perform the same code, and we get the 2.5 value and 1.5, and the optimal value is 13.5. And the Python code for simplex algorithm using SciPy library. SciPy library is the scientific Python library. In that we can import the linprog for the optimization problems. We take the same problem as shown in the example 2 in Python code, and we give the boundaries for the objective function, decision variables 0, 1 and so on, and the result of this function is this, like linprog c coefficients of objective function, boundaries, and method is simplex, and we can get the decision variables results and optimal value. This is the code. As we seen in without using SciPy, we can get same values to 2.5 and 1.5, and optimal value is 13.5. And the area of applications of simplex algorithm, we use this application is in various techniques and various fields. Here are some common applications for simplex algorithm in optimization: resource allocation and production planning and financial optimization. In resource allocation, the simplex algorithm can be used to allocate resources such as time, personnel, and materials, and so on. This way we can minimize the costs and maximize the output. Production planning also, we use simplex algorithm for minimizing the costs and maximizing the profits. In financial optimization, the simplex algorithm can be used to optimize financial portfolios and including selecting investments and determining asset allocation to maximize returns and minimize risks. And here is another example, and we by using SciPy library we can get the answer for profit. First we take the objective function from problem and constraints are given in the problem. We perform the same code, and I am take these as references from YouTube channels and the textbook. Thank you.